A few years ago, in the year 2021, we started with a project called 5G Traffic, and it's located in Aalen, here. I have my own laser pointer, and this project is supported by the German Federal Ministry of Transport and Digital Infrastructure, and the goal is that we want to identify potential of the 5G mobile standard. So we have different partners and we want to analyze different use cases in the city of Aalen. One use case is the safety crossings. We didn't cover this topic. We are focusing on the traffic flow optimization. Can you hear me? Okay. And first of all, the problem statement is we talked with this city of Aalen, where are the problem zones in the city, and also what kind of problems there are, because there are many ways to optimize the traffic flow. And I'm not sure if you can see the picture very well. I don't think so, but you can see on this picture we have three intersections. One is here, the Roschmann-Kreuzung. The second is the Rathaus intersection, and the third is the Rathaus intersection here. And we talked to the city of Aalen and asked them what are the problems, and as you can see here, the answers, we have all the time nearly the same responses, that they have commuter traffic at peak times, and then also the companies were are located in the north side, which you can see is that they will reduce the home office. So they think the traffic will also increase. And one problem of these intersections is that you can't switch to other road sections, means you can't redirect the traffic to some other roads. And what also special, I have to use this. This is a zoom to the intersection. This is the intersection in the north side, the Roschmann-Kreuzung. This is the Rathauskreuzung, and these both are connected by the intersection 3. And the problem is these are the major traffic axes, means there are high amount of traffic there. And what special is on these intersections is that you can, I'm not sure if you can see this, here we have bicycle lane, you have many pedestrians walking here, and you have multiple lanes with trucks, cars, motorcycles, and also buses. And the goal here is that we want to optimize the traffic flow by optimize the traffic light system. We thought about to optimize it maybe with other technologies or ways, like for instance a digital sign, maybe here that say, okay, the traffic light is red, turn down your speed or decrease the speed. But there's it wasn't that easy to do this, and so because there are many let's say problems there, so we decided to try to optimize the traffic light system. And also solution approach, what we thought about is that we call it a rule-based framework. We always need a fancy name, but what the idea is behind this picture is that we want to collect many data, means not only the data from the traffic, means we have induction loops where you maybe see, okay, there's a car in front of the traffic light or whatever, but you also want to collect event data, like is there a football game, whatever. Also look, okay, weather data and so on. We are researchers and we always want much data then. That's so the first thing of all. Also parking data, means there are parking houses there, how many slots are free or empty, whatever. And then also part of the project is that we want to install more sensors. So we also need get more data. These sensors are kind of special. It's about 10 camera systems. These cameras are connected to each other, means that they can create a origin destination matrix, and then we can hopefully see if a car turns here left, that we can see, okay, this car on this lane turns left to this lane. That's the idea. If it's work, we will see. I'm not sure. And the third part is that we want to integrate the traffic controller. The traffic controller in Aalen is from Unix. Integrate means, I think we have to emulate it by ourselves. I don't think that Unix will get us a, let's call it digital twin or an interface, whatever. So we have to develop it by ourselves. And then the city of Aalen isn't that amused to say, okay, let's try it in real world, try it out for 1 day or 2. Say no. So we want to simulate the scenario. So our idea is that we try to get the real world and modeling them for SUMO so that we have a one-to-one copy in SUMO. That's our goal. And for the paper, the scope is that we just want to see, okay, what are the requirements of the project, which we need to transfer or which has to be covered by SUMO. And first of all, to see, this is one crossing. It's a very simple picture of it. I made it with PowerPoint. It looks very fancy, I know. What you can see here is we have here video detections, introduction loops, and what I want to show you with this picture is that we have many sensors already on the crossing. It's not that easy to see all what is here. I will read shortly induction loop. We forgot to translate it to English, sorry. We have video detection, traffic cam, ZD. This one here is unknown. Then we also have sensors we don't know what this is. We received a paper from the city of Aalen with this information. So we also not sure what this is, but there are something. And the idea is that we want to integrate more data sources like the cameras. I told before, they are connected and exchange data via MQTT. And also we want to install roadside units on there to, for example, vehicle 2X. And also considering data sources like Aalen events, weather data, and so on. So means that these sensors will increase. Then I told you that I want to we want to optimize the traffic light signals. Means that we have here a phase transition plan. We have the different phases here, and here we have the transitions. Means I can from phase 1 go to or transit to phase 2 and so on. And we have received this picture here, and now we have to think about how to integrate it into SUMO. And also we have to integrate the traffic controller from Unix, where we don't have any information yet, but the traffic controller means that we have to communicate with our solution with the traffic controller, and then it goes to the traffic light. So the traffic controller can block our request or response. And what we here not see is that we have maybe special events on the street. Means that we have emergency cases, maybe ambulance there. Okay, we have this phase turn all to red so that the ambulance can drive through, but we don't know how this will happen currently. And then I will give it to you. Brauchst du den oder brauchst du nicht?
Ja, vielleicht. So, as Ingo mentioned, it's just a technical concept. It's not, we have no implementation right now. But I like SUMO very much and I want to make it with SUMO. And so we were curious if SUMO provides all the features we need for this project. And we found 4 different fields of requirements for this project: the traffic light systems requirements, the 5G sensor systems requirements, traffic simulation requirements, and traffic flow optimization requirements. And for the traffic light system requirements, we have this, we need customizable TLS programs, and then the TLS can be actuated by sensed by detectors. TLS phases can be switched with an API. And we have interchangeable traffic light system programs. And we need this programmable PLC, as Ingo mentioned, this Unix controller. And so SUMO provides all of them except this very special programmable Unix controller here, which where we need a kind of block logic, something like SPS or something which we need to implement there.
Make this a green check mark.
All right. Is it possible already? Ah, really? Okay, then let's discuss this. So with the 5G sensor system requirements, we have we need a pedestrian traffic light system request button that people can go to the pole there and press a button and are waiting for the green signal. And we need induction loop sense detectors, connected traffic cameras, and 5G vehicle-to-X roadside units. So here is it's for pedestrian traffic light system request buttons. There is a Tracy tutorial. Jacob also mentioned it. Or one of the SUMO team mentioned it, that there is a tutorial. And I found out it's possible with Tracy, but it's not native in SUMO now. So induction loop detectors are also native in SUMO. And these connected traffic cameras, we have these E2 and E3 detectors, the lane area detectors and the multi-entry exit detectors. But I put it as here as partly. Yeah, you see here the completely fulfilled, partly fulfilled, and not fulfilled. This connected traffic camera, I typed it to partly because we can do it for one intersection, but we need it for a connection between several intersections. And I think here we have to go in with Tracy. Or maybe I'm wrong. Okay. And so with this 5G vehicle-to-X roadside units, this is also very special. I think we have to find our own implementation there. Then the traffic simulation requirements are very simple here for you all. I think you're very familiar with this. We need a real-world intersection model, different lane types, customizable traffic sensors, and individual tracking of each entity, which is truly performed all by SUMO. And here then we have the traffic flow optimization requirements. We need a sensor value retrieval with an API, the traffic light system program change with an API, and this PLC Unix feedback mechanism. Because if this Unix system gets a signal, it decides itself if it goes to another phase or not. And so here the first 2 points are performed, but are covered with SUMO. And the last one is partly what I would say, but maybe I'm also wrong here. Maybe we can go into the discussion then. So these were the main requirements which we figured out for our project. I will pass to Ingo.
So after we collected all the requirements, we make a gap analysis, and it ends up with a technical concept. I try to explain. We have 3 parts: reality, modeling, virtuality. Reality means we have the scenario, means the city of Aalen, we have here intersections, lanes, and so on, introduction loop, camera system, traffic lights, and so on. And then we have, or this is the input for the modeling part, where we have, you can see this dot lane here means it's SUMO related content. We need to translate the real world items or entities for SUMO. So we have here, for instance, applications like OSM Web Wizard, where we can convert the maps to, or for SUMO, and also we have here different kinds of sensors, this multi-entry exit detectors for the connected camera systems, for instance, and we have, of course, traffic lights here. That's the modeling part, and then if this is done, we create some or many XML files here, and that's the input for the simulation, for the virtuality. So this is one part here, this other part, and what we are needs to self-develop or collect are the data here. As I already mentioned, the parking data, traffic data, whatever. This is, or we need to collect them and also to analyze them, because we want to optimize the traffic flow. And the idea is then that we have here block self-development, where we have a PLC controller, our rule-based framework, all the sensors like RSUs, whatever, and one part where we have to calculate the current state of the traffic situation, so that if we have the state, we have here our framework, all the sensors and so on, we have a controller who decide, yes, we change the phase or not. It goes back over Tracy and say, okay, go from state 1 to state 3, for instance, go back to the simulation. That's the idea. But currently it's just a concept. The next step is that we try to implement this concept. Means we need to develop the Python parts. Also, we need to collect the data. And also we need some experience by trying out different sensor types in SUMO. And one important point is that we will receive soon traffic-related data. Currently, we don't have many data, traffic-related data. And especially we are waiting for the Unix interface, which data format we will receive, which clock rate, whatever, which information are inside the data. And so we would be happy if you have any experience with emulating TLS, PLCs, the traffic lights, system programs, and the program logic controllers, or you have any tips, you are welcome. Thank you.